Swear?
Okay. All right. I just want to introduce you again. My name is Kate Peterson-Mace from ESNet, filling in for my colleague Jason Zarowski today. Thank you to Azher Mughal for being here from University of Southern California. He's going to be talking to us today about the campus-wide upgrade. So we'll turn it over to you, Azher.
Well, thank you very much for giving an opportunity to talk on the CI engineering discussion forum, and I'll try my best. And the idea is basically that USC has been going through a once-in-a-generation network upgrade. This was a very needed requirement across campus-wide different IT groups, and how we can better support the whole environment. We had a lot of legacy equipment, and this is like a huge transition, and I'll talk a little bit on that. And I'd like this to be kind of like very interactive. Please feel free to stop me wherever you would like to, and then we can continue. So a little bit of disclaimer. This is just so that we can talk about different hardware and software features. This is not that we are going to endorse any vendor, neither we are kind of doing any marketing on behalf of any of the vendor. I just throw that, since this is an educational and academic environment, so focus is on the actual technology. Okay, so USC ITS and the campus at large, we had been looking at the campus upgrade, and some of these features which we were missing is I listed them down over here. The network should be, or the platform or the hardware that you choose along with the software, they should be future-proof, which means that they should be scalable. They should be able to meet the growing needs of the USC, which is hosted in downtown Los Angeles. What this means is that we have games that happen in Coliseum. Every other day, every weekend, every month, there are a bunch of, for example, football games and others, and then we need to support all of them. So imagine thousands of users who go over there, and they're looking for a very stable and highly reliable network. For our own ops teams, should be operationally easy to understand, nothing new, which the engineer needs to learn. The network core with the lowest latency which is possible. Deep buffers at the edges so that we can absorb the traffic for our co-location customers and for our data center customers where we have, for example, storage appliances. Port density, multiple speed options, software support for the SDN. Custom programming that can support equipment to be integrated with various northbound applications. In order to migrate from our legacy environment, and I'll show the diagrams later on, we have like hundreds of thousands of VLANs which are stretched across like 280 buildings. And operationally, it is like a nightmare to manage them. And while we will be doing this transition, we need like the support for the VXLAN so that we can transport our traditional VLANs on top of the layer 3 using the VXLAN. And we thought that maybe BGP EVPN is better for us in such a scenario. And vendor support for faster development. So we looked at the Arista hardware. We did went through, for example, parity matching with Cisco, Extreme, Aruba, and then the Arista. Arista's team was kind of, very cooperative with us, working on different scenarios, going from spines, splines, leaves architecture, which kind of equipment to use where with different testing scenarios. So some of the equipment which is like off the shelf available from Arista, I have listed these over there. We are using a larger chassis for aggregation, which is a 7504R series platform. 7280Rs also with the debuffers, 7280QR also along with the debuffers but with higher core density. 7050 copper or the fiber, where we have to connect different data center switches and servers. For lowest latency, for example, for the spines, where they are connected everywhere at 100 gig, and they do not need to absorb any packet spikes. We chose the 7060 CX2s. In fact, the newer versions, we still have some older, the initial releases, 7060 CX. I listed down some of the port buffers which are available on some of these platforms. All these switches, they have different blades, different combination. For example, in the 7504, you can have 100 gig blade with 32 ports of it. You can break those ports down into 25, 50, 10, multiples of 10, and 40 gig. These switches support ER4s, LR4s, SR4s, SFP+, and different variations of connectivity. Then we went for HPE or Aruba hardware for our edge switching gears. On the left side, I showed this FIT400R series of switches, and down there is a smaller version, 3810. We also have 8-port or 16-port switches from Aruba, which are like 2930s. They all support VXLAN, though the control cards are a little bit slower compared to the Arista. Because these are like ARM-based processors which are on these switches, but they have like all the major bells and whistles, like they support VXLAN, they support layer 3 routing, they support 10 gig copper ports, they support dynamic trunking protocol, VSF, virtual switch forwarding, just like aggregating different switches together, controlling the control plane. And on the right side, I showed a diagram, picture of a 7220 series. This is for our wireless LAN controller from Aruba. And this is basically, there are different versions, smaller, larger, based on the licensing and the number of users they can support. And in addition, there are many virtual appliances which Aruba offers to control the wireless networks. Our whole campus is all running on just on Aruba, and we have different applications like airwaves, and now we are also looking at the newer company which they have acquired recently is the Cape Network, which is for the network analysis. This is just like another end support, just like a NetBees, where you have active devices which you deploy across the campus, and then they report on a dashboard on the performance. So, which is also very helpful in getting the right performance and understanding what you are deploying, and where you have blind spots and what is the throughput different users are expecting. Some of the interesting features that are there in Arista OS, and we are actively using them. I think I missed some of them, but a few of those things over here are that these switches are just a very fast Linux boxes. They are they run on Linux, and they talk using the Broadcom SDKs libraries with underlying ASIC hardware. In different models, you have different options of the number of routes you can put into the chip. like 7280s, they can go up to 2 million in the R2 models, while 7060 you can go up to a certain number of thousands of routes, which is good for when you are doing underlay and overlay, where underlay environment needs only to know about the core of the network, while X switches, where you have the debuffer based switches, you can have several thousands of routes. Single operating system is very convenient. Same OS goes to all the equipment, whether it is a chassis, small switch, or one kind of ASIC or the other kind of ASIC. Doesn't matter. Linux shell to write your own code. You can log into the bash. You can use, for example, smoke pinger. You can deploy that smoke pinger onto the Arista, and it will keep sending the alerts back to your dashboard. You can have an iPerf on this Linux box, though it is limited to the PCI bus limit on the controller that connects with the ASIC. But iPerf is available. Multi-chassis lag is very convenient, where we have to provide active lags downstream. For example, if you have 10 gig, then you're providing 10 gig downstream lags, and both links are active, easy to troubleshoot. Virtual ARP. If you have, just like HSRP or VRRP protocols, Arista has introduced the VARP. VARP provides active if you have multiple links on both of them. Then they have the Cloud Vision product. We are actively using Cloud Vision to, and I can show you the application by itself as well. It is used for pushing the firmware to a full set of containers or individual switches. You can create an inventory, the topology as well, and then the telemetry. Telemetry is also very important, where you see the routes which are flapping, and the other statistics from the switches. LANs to analyze the microburst, DANs, tap aggregation. DANs is a little bit tricky, because if you do the tap aggregation, then you lose all the ports within that plate or within that switch, which is a little bit of challenging, that you dedicate the hardware if you have to use the tap aggregation. Telemetry, again, as I mentioned, for the Cloud Vision, it's a real time. We are using it, but not that extensively, but we are trying to understand more on how we can better use the telemetry. OpenFlow is available in 7060, though we are not using the OpenFlow. There's another feature called as Direct Flow, which is available from Arista directly. What it does is that, just like in OpenFlow, it can put some of those specific rules on top of all the rules which are in the ASIC. Any questions? Please let me know. Some of the other diagnostic tools available in the EOS. EOS is their extensible operating system, their name of the operating system. Bash, you can run, by the way, your own BGP daemon if you don't like the standard BGP daemon which is provided by Arista. TCP dump we actively use in troubleshooting, for example, DHCP based scenarios. Event manager, tracing, identifying issues for the logs. So tracing is also good. For example, just like syslogs in Linux box, you can look at all the logs and then filter out for different daemons. So technically, basically, when we use, for example, Cisco or HPE, then we have to use certain special debug tools to understand what is going on, and most of the time it is all cryptic. But in case of this Linux-based switching system, we just look at the logs, and these are all very understandable. REST flaglines and port mirroring are the general features. I'll talk a little bit about the Arista SysDB, which is very useful, and why this was one of the core features why we chose Arista. SysDB is the central core database or the repository of whatever is happening within the core of the Linux operating system in Arista. It has all these features which are listed, for example, convergence, programmability, patches like in-service software upgrade, and the scalability as well for different merchant APIs. So on the left side, we have different applications like VXLAN, CLI. These are all like small applications. If you like to run your own application, you just connect, patch it with SysDB, and SysDB will start providing you the information, or you can start polling from the SysDB. Both asynchronous or the polling is options are available. Different tools, for example, Splunk, Puppet, Chef, XBGP. These are the additional tools which you can run, connect with the Arista gear, and all the standard hardware resource features like TCAM, fax, and the matching is available. For the hardware resources, of course, there are different equipment have different chips. So based on the exact chip that we are using in different devices, the number of routes and how, for example, when we see the exact match, then it also calls as the route optimizers. For example, Arista optimizes, and it can, instead of using looking for a huge number of memory into the switch, it can still program a large number of routes in smallest possible memory. This is our traditional four corners here at USC. This is where we divided and brought all the VLANs that connect to around like 280 buildings across the campus. So UCC, PHE, these are different names of the buildings, like PST, Cal, Little. PST is the parking structure, PHE is physics, and the UCC another corner. And each corner kind of handles like a quarter of the buildings. We also have other campuses, for example, health sciences, Keck School of Medicine. Those I have not shown over here. But this is the core. This core was originally built like on Cabletron using their SFS technology. We are still running Cabletron after like for more than 25 years, and we have a large inventory of their blades and the chassis, and they still work, they still function, though we do not have any support, and we are replacing actively using this current ongoing project with HPE or Arista gear. We had different challenges, like each blade can just on 700 megabit per second, I will start seeing the CPU issues. If the blade, if the port is not properly configured for a certain number of tags, and you get a lot more tags coming in, meaning VLAN pruning is not being done properly, then CPU on these blades go very high and they will start dropping the packets. A little bit definition on what we are using here. So spine is the shortest path from east to west. This is for the campus. This is how we use, within a campus is usually used east to west. North south is when we go outside the campus and inside the campus. This is where we need the lowest possible latency, and that's why I mentioned earlier that we are using the 7060 switches, which have the shortest possible latency from port to port. Leaves, these are the leaves which connect to the spines. We are using BGP, and they connect to the edge servers. These leaf switches connects to all the spines, and as mentioned earlier, they require the deep buffers to absorb the bus. We started looking at collapsing the spine and leaf in certain areas, but then we opted more for the spine and leaf architecture. For the splines, what would happen is that, in fact, we'll have to use large chassis where it will be hosting the spine part of it, and the leaf itself will go into the spine, which means that in case of any failures, there's a single box, a single point of failure in many of the scenarios. And a future support, if we are going to buy the new equipment and having like 13 or slot chassis, it is costly to replace those larger boxes. Plus, this is spline is not scalable in my view, that with a spine and leaf, if you need more ports within the spine, you can easily create another set of spine. If you need more leaves, you can kick in a bunch of more leaves, and which is very cost efficient as well when we are dealing with a large scale deployment in the campus. This is how we have this. In one of the scenario, we have the data center spine, where the leaves are connected to the spines. We did not need inter-spine connectivity. All the spines are connected to the leaf switches, and this is how we are doing right now, where we have the layer 3 connectivity using the VXLAN type 5 for BGP EVPN. I'm showing here some categories, for example, how we have different options available for people to host their devices. For example, production, development, services, utilities, and management. Within the development or the test scenarios, we have different set of security locks as well. In production, we have different set of security locks and different zones. So zones and security lock, this is how we have secured the environment as well. I have not shown the firewall infrastructure. But there's a firewall. So eventually, actually, the traffic flows to the service leaf and to the firewall structure, and then it goes out to the spines. And in the utilities management, this is where we, for example, we connect different network monitoring applications. And there's another set of leaves where we have the aggregation devices, for example, Aruba wireless LAN controllers. Another example where we have co-location spine leaf architecture. These are different areas, different co-location rooms, and this is how we have connected. All the core is 100 gig, all the spines, all the leaves, they're all interconnected via 100 gig. Only at the edge we are using in the buildings. In some of the buildings we are using 40, but and in many of the other buildings we are using 100 gig as well. So the goal is to provide the maximum throughput with the parallel lengths. In co-location, we have around like 40 to 50 customers, and these are distributed across 2 large data centers within the same building. So this is the BGP. This is the BGP EVPN type 5 that we are using across the whole fabric. Each leaf pair across the buildings, for example, there are different acronyms on the diagram over here. For example, CAL, PHE, this is one of the region. These are the 2 buildings and which serve different other buildings. For example, another one, NRTHSP, this is our health science, and just like others. These are showing 2 set of switches, which are MLAC, which provide downstream connectivity to the building, so that the downstream has parallel uplinks for using LHCP, active throughput, VARP, and all those standard protocols that which we use. There's a central AS number, and all these leaf pairs have their own AS numbers. This is used because VXLAN is well supported in the Arista using the BGP, and we can easily track each of the subnets and the announcements, the users, and the VXLAN announcement of the MAC addresses from one point of the campus to the other point. We are also using VRFs, virtual routing forwarding, within Arista. We have not extended that yet to HPE. If there's a need, we may extend. Though each building has like a set of different services, like you need to have voice over IP phones, you need to have some users asking for a DMG, like cameras, students, Wi-Fi, our own gear. So we use multiple VRFs to segregate all that traffic, and then those VLANs, the edge VLAN, they terminate into those VRFs, and those VRFs then go to the core, and at the core, then we decide that which VRF is allowed to talk with others. This is kind of very scalable to connect to the core, and creating VXLAN is also it's very simple. A few lines of code, and then you have VXLAN from point A to point B. We're trying to use the config-lets from the Arista Cloud Vision, so that those config-lets can provision the VXLANs and some new leaf pairs whenever there's a need. There's a good section within the Cloud Vision, and I'll show you in real time after this presentation. I talked about the VXLAN Type 5. This is the VXLAN, the other version of it, which is the Type 2, where if you would like to create an easy-to-way, for example, between two switches, transport the VLANs across over the layer 3. This is the easiest possible scenario. You do not need any control plane architecture, just like BGP. You simply run HER on Arista or Cloud Vision Express on the Arista on a VMware, and or statically point to each of the box, and and the VXLAN will then transport those VLANs. Also, another very cool feature, just like we use in our out-of-all environment or any other NSI feature set, VXLAN provides VLAN translation. So if there's a VLAN 10 on the left side, you can have VLAN 20 translated on the other side. This is one of the examples where we have the layer 2 boundary downstream, and where we have layer 3 upstream connecting to the core. I showed the MLAG here. Usually there are 2 links for the MLAG, so that and the MLAG is put in a port channel configuration. So that if one of the ports within the MLAG is down, then the port channel will still remain active. Otherwise, what happens is that, and this is what we observed in certain outages, that if any of these MLAG switches, they lose the connectivity among themselves, then what happens is that they become like a split brain, and the downstream switches, they do not know what is the upstream switch, and then they start losing like a 50% of the packet. Let me see if there is like a chat message, I think. Something in the chat. Oh, okay. We started deploying this with our village, which was one of the milestone, and the first set of 6 buildings which were deployed. We used the equipment that we use in the village is which I listed over here. This includes Arista 7280Rs, HPE switches, different variants wherever we needed more ports, and the Aruba 802.11 AC, Aruba 325 access points, and .1x MAC-based auth for the user authentication. Again, this is a little bit more on the VXLAN with different models. So we can discuss more if needed. What we are using is the last one, the EVPN. So some of the monitoring application that we use, for example, for our wireless infrastructure, where we have the Aruba controllers and the airwaves, and some external products, for example, warnings from NINSA, which basically actively track all the users, provide deep information, and for example, how much traffic is going over the Netflix, YouTube, Facebook, Spotify, and all that stuff. Airwave provides like deep info within the controllers, and while Voints basically provides like a DPI kind of thing where we can track the MAC address and how and where this MAC address and what it is using for over a certain period of time. So this is very easy to troubleshoot in the troubleshooting scenarios, and understanding the overall need of the campus and what the users are using and the application which we need to better support, whether it is east-west or northbound. Mostly it is northbound, as you see over here. Some of the network monitoring application that we actively use over here is Rancid, which is very common everywhere, to back up our Arista gear and HPE and wireless LAN controllers from Aruba. We also have like Fortinet firewalls, but we do not use Rancid for the Fortinet because it's like a different security domain, and we have other tools like FortiManager to manage the archiving and backup for the Fortinet. StatSeeker provides us statistics just like Cacti for individual port analysis and trend analysis. Arista Cloud Vision product that we use to push the images, create the tasks, and integrate that with the ServiceNow, so that whenever there's and we are still working on the integration part of the Cloud Vision with the ServiceNow. What this integration will allow us is that whenever there's a request in the ServiceNow for a change, that this group of switches need a firmware upgrade, there will be a change task or tickets will be generated in the ServiceNow, which will be communicated to the Cloud Vision. Cloud Vision will have a task where the software will be planned provision at a certain time, and then once that task is being approved from the ServiceNow, that task will kick in, and then it will upgrade the code onto the switches. Perfsonar servers, we are working on upgrading the infrastructure across the campus. What it includes is that we are deploying some 100 gig and 40 gig servers, and this is part of this larger upgrade project. The servers that we are going to deploy will have iPerf, Mellanox NICs, Mellanox 100 gig NICs that supports InfiniBand, RDMA, and also standard Ethernet. And in some location, we'll be adding some high-performance DTNs that will have liquid storage cards, so that if there is some application within the researcher or some other group which wants to move a bulk of data and want to know that whether the network really performs and IO also performs, then these DTN boxes will be used. We are also developing some custom firmware with the vendors, so that instead of running iPerf, we can we can generate or originate the frames inside the NIC of the network card, so that that will help basically offloading a lot of stuff from the iPerf and the OS and avoid tuning and the servers. Spectrum is our previous generation of we are also using the SolarWinds, and Spectrum is the previous generation of software which monitors the entire campus. Plus, we have a lot of homegrown systems.
Azher?
Yes.
We have a few questions.
Yes, I just noticed that, and
Several are wondering, you referenced a village when you were talking about wireless monitoring.
Yes. So, well, Santa does not live over there. That's a village. Village is a terminology where we have our student dorms. It's like a little bit modern style of dorm center within the campus where we have Trader Joe's, where we have Macy's, where we have cobblers, and many other shops for your eyeglasses and many other shops. So this is like a all-in-one in-house area where you get all the services, and the students have very fine living places. Many faculty members also live over there. You have kind of small suites or individual dorm rooms.
Great.
And the whole village environment is connected with the multiple 100 gig backbone, so you get the maximum throughput that we can offer over there.
Okay, thank you. So Santa could live there. I'm just kidding.
Yeah, so it's not a Santa dorm.
So the other question is, which spectrum are you referring to? Is it a Prisma or I guess CA or?
This is the spectrum from the CA systems. We are still running a little bit older version from 2016, and we have not upgraded to the latest one. And one of the reasons was that the licensing fee for Spectrum is a lot, and maintaining Spectrum is another like full-scale job for a team. So this is where we are trying to avoid using Spectrum in the coming years, and we are trying to use more like SolarWinds or other tools which we are still debating, where we have better trend analysis and better alarming system, where we can have alert based on the initial issue rather than the issue which happened at the end. So it can give you a little bit more analysis rather than we'll go and go fight with the application. The application should come back to us.
Great, thank you for that. We have one more before you move on from Don Westlight. I'm wondering if you can comment on the VXLAN decision. I'm wondering if you're happy with the general life cycle of support for distributed segmented network service, if you considered MPLS.
Right. So we didn't consider MPLS because in order to run MPLS, then we would have to spend a little bit more money compared to what we are spending now onto the Arista gear. VXLAN is another like a transport tunnel where wherever and it is very easy. Basically, its configuration is way easier compared to when we use, for example, MPLS. Of course, experience varies, but in our decision and in our analysis when we were going through different products, we thought that VXLAN will work better for us. And Arista is well supporting it in either Type 2 or Type 5. Well, and we didn't choose the Type 2 because Type 2 is non-scalable, and Type 5 is highly scalable and easy to troubleshoot.
Great, thank you.
And I'm willing to more questions on this VXLAN, and if we need to have some kind of discussion.
Okay, looks like we have one more about requiring 802.1x certificates, and then maybe you can answer that and we'll let you get through your presentation and then do Q&A time allowed.
Right. Yeah. So we are using 802.1x, and I missed some of the things in the presentation is that we are using ClearPath from Aruba and BlueCat from BlueCat Networks. ClearPath is used for all our 802.1x initial authentication, and we use Active Directory for where we have the user accounts. So Aruba, whether it is the wireless clients or whether these are the wired clients, These are we are using the MAC-based authentication. For the certificates, we are still debating how we can use it because we have some legacy systems where they do not support the certificates, and we need to upgrade those before we can migrate to a larger level, larger scale, so that we don't have an interruptions. So do you have any clients that are unmanageable or clients that you do not have the ability to install certificate? Yeah, that's one of the issues. For example, some of the voice over IP phones, they do not have support the certificates, and these are the older Avaya phones. And we have an ongoing project where we need to replace those to replace those devices so that we can have those certificates which are supported. And many of those, even phones, they do not support 802.1x. That's another challenge. So we have to use PSKs with those kind of phones. So that's another challenge which we are going through. But we have a separate project, and we are working to find some money and then replace that set of gear to have like a homogenized environment.
Great, thank you. Alex, did that answer your question before we move on? Oh, looks like there's a follow-on.
And for the ClearPass, we found it very useful because it is well integrated with HPE gear and all the products from Aruba. It supports TACACS authentications to all the administration accounts across different gears. We have Cisco, HPE, Aruba, and Arista. Roles properly work. All the configuration commands, wherever we need to lock them down, they all work fine. ClearPass has different portals as well. For example, for wireless, if you have to sign on the users, it works fine. You can create custom pages. It does not provide yet the multi-tenancy feature, so that we can provide different IT groups within the campus where they can provision part of it to part of the ClearPass by themselves. So we are designing some custom device registration portals, which will be connected to the BlueCat for our DHCP and static IP preservation and DNS, and with the ClearPass for our authentication process using the REST API calls. And that project is about to be launched by end of September. So this is one of the very needed feature which all the IT departments who manage their own IT groups. For example, we have School of Marshall and Domeside, Viterbi, School of Engineering. They have their own hundreds of users and they manage their own data centers as well. So this is how they need access to these devices. For BlueCat, we are using it as DHCP assignments. The BlueCat can also reserve the IP address. It has different scope. Basically, it is a fancy design just on top of a standard named DR bind in Linux. Though it is like a very mature product, and you can have a cluster, you can have high availability, you can have VIPs as well. It provides multi-tenancy. You can log down users to individual subdomains, to individual IP subnets. And you can provide individual accounts, read-only with limited management, and you name it. And upgrading BlueCat is very easy.
Excellent, thank you.
And we also have some homegrown systems which provide us CRC errors on usual basis if there are some links which align with dirty. And we are working on the optical as well, that how the optical receive levels are being changed at different locations within the core. So we'll see those as well, so that we can better monitor not just the error, but also the optical systems. In addition, some of the things which I have not listed, we are going to purchase Sienna web servers. This will be to connect to our upstream provider, which is Osnetos, and also to our remote regions like health sciences, which is about like 10 kilometers, up to 10 kilometer distance. This will provide in total what we are looking at as about 1.6 terabit per second backbone, highly redundant fashion. And web server is good that it provides you optical add drop and provides you different level of input optics, and you can use any vendor optics to it. Then comes my last slide. Our transformation, which is a 2 years project, we are almost half in the way, and our almost 100, close to 140 buildings are already done, being upgraded, which were easy to do. Some of the buildings where we had to upgrade the IDF and other infrastructure facilities, we still need some remediation, and those will be the next year. Our core is all ready to take any kind of load, though we still need to work a little bit on security side on how we can save this multi-100 gig core from DDoS, and to better understand and launch the DDoS ourselves and go through those scenarios. So this is one of the things where my team is looking at. Arista, their team was very supportive in all this design and in fixing any of the bugs. We had many bugs on the way, and their support is very fast and highly responsive. Software-defined technologies, just like OpenStack or NSX from the VMware, we have done deep testing on those. This is well supported in all our core, and we are hoping to deploy those infrastructure into our data centers. We have done a lot of testing on the NSX, and it's virtual firewalls and the VMs. Some of the firewalls that can be deployed and added within the NSX. We are hoping to soon deploy full-scale intelligent monitoring and telemetry. This is one of the last pieces of this puzzle, where we are going through the process, and we are still kind of debating which will be our final applications. Well, this concludes my presentation here, and I'd like to open the floor. If you have any questions, we can talk about.
Great, thank you so much, Azher. It looks like we do have one from Jim Warner. He was wondering if Blans has given you insight on how the network operates, or is that in the future?
That's still part of the future. What we are doing right now is through the cloud vision and through the telemetry. And what telemetry offers us is kind of all that features which Blans is providing. And it supports, it provides you all those very tiny spikes, which we can see on the CVP.
Okay,
but definitely this is one of the area where we need to evolve further and integrate well in our environment.
All right. Thank you. And a question from Tim Chown. Is there any comment on plans that you may have for automation?
Yes, so we use Ansible in deployment of most of the VXLAN infrastructure and the BGP. We have playbooks for the Ansible, and we use those playbooks to push the configs, and those are very easy to write and very helpful. You don't need to work on writing the code. And along with that, Arista Cloud Vision is also very good, where it provides you configlets. Configlet is, for example, you want to provision something, you write your own config, it will generate the exact code for you, and you can modify that Python code on the fly as well. And so both options are available. What we have extensively used so far is Ansible and the playbooks. Configlets, we still need to mature ourselves on actually how to better use them. But I've seen those configlets and I've played with them, but not at large scale.
Great, thank you.
Sorry. So was there a design that includes centralized firewalling or just server or location specific firewalls? So a very good question. So we have our border firewall. We use Fortinet for all our core firewalls, and Cisco ASAs for our VPN concentrators. Now, Fortinet is used for our border, for our co-location, for our data center, for our PCI, to securing the PCI, and any other environment where we need to limit the scope of the traffic. Now, we are using clusters of the Fortinet firewalls and using the newer gears like 7030s and 7060s. We have done extensive testing using Ixia 100 gig application testers, where 7030 firewall and 7060, they have shown that they can push the traffic at line rate, a real life scenario where you are sending a lot of HTTP traffics and a mixed traffic as well, like DNS, FTP. So Ixia can generate those kind of traffic. We have not used the Spirent, but we use the Ixia, which is about the same thing, to test these firewalls. And so so we use Ixia for the real time. But for if you think about, for example, Science DMZ, then we have not done large flow testing from these firewalls. And this is one of the area where we need a little bit more testing, that whether we'll have a bypass Science DMZ or the Science DMZ will still go to the Fortinet firewall. Hopefully it will still go through Fortinet because of their performance so far is actually the line rate compared to the older gears, or from Palo Alto or from any other appliance. So I'm not sure if that answers your question or not, but this is how we use. Okay.
Thank you. We have, it looks about 5 more minutes if anyone else has questions. Well, maybe typing, I guess I have one, just a kind of a higher level one. So at what phase, so what phase is the upgrade? Is it already done, like the first phase already done and you're going to go back, you know, budget allowing, or how far into this process? I know you have the design and everything, but as far as the deployment goes, where are you?
So in this secure and connected project, we have finished our core. We have finished our campus leaf infrastructure. We have like half through in our building upgradation project, and building upgradation also includes our wireless infrastructure upgrade as well. And by the end of this project, we'll have above like 12,000 access points deployed. And so far we have close to like 3,500 access points which are on our new gear. So we can say that we are like almost 50% into our edge deployment of the gear, and 100% within our core. Core is also now like a fully redundant with our uplinks, with our uplink provider, which is Lost Netos under the Scenic infrastructure. And we have multiple paths, multiple failure cases as well. And this is about like a multiple 100 gig backbone. So our next cycle will happen, I think, once we'll be finished with this upgrade by the end of the next year, by the end of 2019. This is what we are projecting at. And after that, we may go look at our increased throughput requirements in certain areas, since our core is already multi 100 gig infrastructure. So we do not feel that there would be large scale upgrade which is needed for within our core, but at the edges where maybe more scientists, when they will be feeling that now they can deploy their own gear and get like a higher throughputs, and many of those research group have already talked about that, and that's why we provided, in for example, in one of the building 200 gig, and majority of their switches are all 100 gig with all 100 gig ports which are available, and they ask for 100 gig at the workstations. And they have some specific biology appliances for the storage and other stuff, and for microscopy, which requires those things. So the researchers are getting this idea that they have this new network, which once their building will be upgraded, then they will be able to use, and this is when we will see high requirement coming in about 2 years. So for question, yes. For the optics, yes, so we are using FiberStore third-party optics, and they have been very stable so far. What I have seen, and in our field services as well, the techs, what they have noticed is that sometimes the latch does not fit properly, and since we are going through this transformation and there's a lot of hands into the we're working on the actual patch panels. So if sometime mess around with the fiber, then the latches on those optics or the cables, if they get loose, then there's a flap. Otherwise, optics are so far very reliable, and they are very, very cheap compared to the Arista from their own. And FiberStore is providing the ER4 as well for the 40 gig reach, and we have tested that from Los Angeles to Marina and Del Rey, which is like above 10 kilometers, and it worked very fine. And we have also used in some of the gear Champion optics. They're also like a rebranded optics, so they also work in HPE. Though in HPE you have to enable, and also in Arista you have to enable the service unsupported transceivers, those commands, where after that they enable it. And in the show inventory you can see all those different vendors. And by the way, there's also a small like $100 device available from FiberStore, which can reprogram the optics. So if you have like optic from HPE, which you would like to use in Arista, it can program from HPE to Arista. Right? This is like a 3-socket small device that works for SFP Plus for 10 gig, for 40 gig, and for the 100 gig.
That's great. Thank you for that, Azher. All right. Well, we're actually at the top of the hour exactly. Well timed, everyone. Just wanted to thank you again for your time and presentation and all this information. This will be uploaded to the usual spot. Information on that will be going out. And thank you all for joining.
Thank you very much for having me. And I would love to have some feedback so that I can improve this presentation.
Great.
Thank you.
All right. Thank you all. Bye. And have a great weekend.
Bye.